Okay, in this tutorial, I'm going to have a look at what dot maps are as a method of presenting data on a map to allow you to determine a pattern. I'm also going to talk about the suitability of using this technique, along with the strengths and some of the weaknesses. Now, dot maps are often seen as the opposite mapping technique to choropleth or shading density maps, because many of the weaknesses of choropleth maps are actually addressed by dot maps. However, some of the weaknesses of dot maps are therefore actually addressed by choropleth maps. And that may make us have to think very closely about which technique they want to use when they're presenting their data and which one's going to be more effective at showing their information. Now, a dot map is actually quite a straightforward technique. It's where one dot on your map, for example, the one I'm pointing to here, represents a predetermined value. So in this world population map, a single dot will represent 100,000 people. Here on this map, we can see a dot, a red dot, representing 100,000 Hispanic people. Here we can see different colored dots representing 20 immigrants from different ethnic backgrounds. So the different colors, the orange, for example, represents clusters of people of European origin. Likewise, red represents clusters of people of Mexican origin. So it allows us to see patterns of different ethnicity. In this case, this is New York. Now, before we have a look at some of the weaknesses, let's just consider some of the other important points about putting on a dot map. So a dot map is more effective than a choropleth map at presenting the actual location of the data, because a choropleth map deals with the average across a whole area. So for example, here we have North Dakota, and if we knew the population of North Dakota, then we could, the average population or the average, let's say, Hispanic population, we could select a color. But actually, the Hispanic population may just be located in one particular area within that state. A dot actually allows us to see the location of where Hispanic people are, rather than just being an average of a whole area. So, for example, we can see in some states in the US, like California, the Hispanic population is quite evenly distributed around the Californian state. Whereas in certain other states, we can see that there's only certain locations where they're located. For example, in the Midwest here, we can see certain areas because the dot represents the actual location they are at. So that's its strength. It gives a real pattern of change. It doesn't have the abrupt boundary changes that we see with choropleth maps. It also allows us to see very sensitive patterns of change across different areas, whether it is the world, where we can see real clustering of people around the coastal regions of the planet, or whether it's America with Hispanic populations being dominated in certain states. And obviously, more than likely, we'll see that these dots correspond with large urban centers in America, or whether it's the ethnic origin of people, and we get to see a real pattern because the dots' colors are changing to represent different ethnic groups. And we can see a very effective clustering of different ethnic groups in the greater New York area. Now, there are some real limitations, and this first map here really does highlight that first limitation. It's when you have a lot of something in one particular location, and your dots, if you have, for example, 200,000 people in a city, then where do you put your second dot? Well, you have to put it to the side of the first dot. So the first problem is the dot is no longer actually sitting on its actual location where people are. And if you have 300,000 people, then you have to start clustering your dots around the actual location where those people are. And it ends up becoming very crowded, as we can see here in Europe, for example, because the dots all start overlapping and merging into one, where we can no longer even see the individual dots. It becomes very difficult to read. However, if you're just trying to emphasize the clustering of human beings in certain areas of the planet, then it doesn't really matter. If you are wanting to actually see the precise location of these different people, then it would matter. Here we can see another problem, and that is whatever you decide your dot value to fall at. Because if you have 999,000 people rather than 100,000 people, but if you just have 99,000, then you will not have a dot in the location. So even if you're just 1,000, as a matter of fact, if you're just one person short, so 99,999, then it won't get a dot. But if you over that number at 100,000, you get a dot. So when you decide your cutoff location, as you can see what your dot value going to be, then that becomes the criteria for placing a dot. There may be, for example, up here in this state, 99,000 Hispanic people, but we don't see that they're there because they don't quite meet the threshold of the dot. So that's one of the drawbacks of the using dots. Now, one of the things that you're going to want to be able to do with this technique, but just zoom out, is talk about the strengths of the technique, talk about its weaknesses, potentially make a contrast with this technique and choropleth mapping. So we can see here, if you just want to pause and read this, some of the reasons and strengths of actually using the technique, and especially in contrast to choropleth maps, but then also some of the weaknesses that I've already discussed. You might want to pause this and also read through and make sure you could talk about the strengths and weaknesses of this technique in contrast to choropleth mapping as a technique.